Alright, welcome back to AI with Justin. This video is part 2 of 2, where I'm walking through the history of LLMs and VLMs to date at a high level. I made this timeline to guide the video, and I'll be adding graphics and commentary as I walk through it. Part 2 includes 2021 through the filming of this video in mid-2023. As a very general statement, LLM research from 2017 through 2020 was centrally based around realizing the effect of scaling transformer-based models and implementing them, whereas 2021 through 2023 has shown a much broader range of topics, including human preference alignment, external information retrieval, mixture of experts models, multimodality, and the first LLM applications to break into the mainstream public's attention. Okay, let's begin, starting with Clip from OpenAI in January of 2021. Clip introduced a method of producing common embeddings for image and text encoders. More specifically, researchers devised a contrastive method which could learn to represent image and corresponding descriptive text embeddings to an identical or very similar latent result. On a side note, a multimodal model is fundamentally not a language model. A new term has become popular to describe these models, incorporating both text and image inputs: visual language models, or VLMs. Also that month was the first large-scale implementation of mixture of experts, or MOE. MOE is a sparsity design which uses a method of applying different parameters for different inputs. So in other words, not all parameters will be used for each input, and similar inputs will ideally use similar parameters. The idea behind MOE is that you can scale model complexity without increasing computational training cost. However, note that the required memory and inference cost will still increase for these models. The switch transformers implementation of MOE was adding a switch layer, which would route inputs to different sets of feed-forward networks. The authors also raised the topic that multimodal models could likely benefit from MOE designs, as different parameters could specialize to different forms of information. In May, Google announced Lambda, the successor of Mina. Lambda had a high parameter count, was intended for dialogue, and had a few interesting strategies and components. Like Mina, Lambda was fine-tuned on manually annotated responses, except instead of sensibleness and specificity, the annotations were based on qualities of sensibleness, interestingness, and safety. Further, Lambda was trained using imitation learning to utilize numerous external tools, including a real-time clock or calendar, a calculator, a translation system, and an internet search information retrieval system. Lambda has had 2 major releases, the second in May of 2022. A Google researcher publicly claimed the model to have sentience in June of 2022, stimulating conversation of what sentience actually is and increasing public discussion of AI. Back to 2021, in August, Microsoft and OpenAI released GitHub Copilot, powered by Codex. Copilot is a coding assistant available on major IDEs as a plugin and has become quite popular. Codex is a branch of GPT-3 fine-tuned on a code corpus from GitHub, and now in 2023, Copilot X is available, which uses GPT-4 as its base model. In October, Microsoft and NVIDIA released Megatron Turing NLG, which was a scaling of Megatron LM using an optimization library named DeepSpeed. While it didn't really bring new research innovations, it did provide a standard for engineering models at scale. The model was more than 4 times the size of GPT-3 and furthered state-of-the-art performance in numerous categories. In December, Megatron Turing NLG's parameter count was actually doubled by GLAM, with the contingency that GLAM is another MOE implementation. The paper brought new methods of stabilizing MOE training, which had shown to be stubbornly unstable. Also in December, OpenAI released WebGPT, which applied behavior cloning to use a text-based web browser powered by Bing, followed by RLHF with intent to increase helpfulness and accuracy. Notably, their document retrieval included references, which greatly helps with model explainability. Around the same time, DeepMind published two important studies, the first being Retro. Retro, like WebGPT, was focused on external information retrieval. Rather than training an explicit information retrieval mechanism, DeepMind chose to integrate information retrieval directly into the transformer architecture. Their approach involved generating embeddings of the external database using BERT, performing nearest neighbor search between the input sequences BERT embedding in the external database, encoding the result further, then integrating that result into the main transformer model through cross-attention. While the approach had a major downside of maintaining a fully embedded database, it also showed very impressive performance, outperforming drastically larger models in many tasks. The second study was Gopher. Gopher used GPT-like architecture and was high-performing, but didn't bring a whole lot of new technical innovation. The research paper, however, did come with the observation that reasoning-heavy tasks were improving at a lower rate than knowledge-intensive tasks. At the start of 2022, OpenAI released InstructGPT, which was a very successful study of human preference alignment. InstructGPT was GPT-3 first fine-tuned in a supervised fashion on human written instruction following demonstrations, followed by RLHF on a reward model trained on human rankings of responses. InstructGPT is a sister model to ChatGPT, with the core difference being that ChatGPT was optimized for dialogue rather than specifically instruction following. OpenAI noted in their blog post, one way of thinking about this process, referring to alignment, is that it unlocks capabilities that GPT-3 already had. 2 months later, DeepMind published a follow-up study to the previously mentioned Gopher. The study's main conclusion was that Gopher and other models of their size were likely undertrained, indicating that the commonly used scaling laws needed refinement. They supported their claims by producing Chinchilla, which had a compute equivalent training cost to Gopher, but a much lower parameter count and trained on more total tokens. Chinchilla was able to outperform Gopher on most tasks, despite having 4 times fewer parameters. A month later, Google released its technical report on Palm, its largest non-MOE model yet. Discontinuous improvements for some tasks with scale were observed, strengthening the case that complex task capabilities previously unreachable could emerge simply with additional complexity. Palm's research paper also gave many valuable insights to challenges, techniques, and engineering used to train the model at its large scale. Around the same time, DeepMind released Flamingo, which was a successful application of clip-like embedding sharing to pre-training LLMs. Essentially, the researchers were able to train clip-like intermediary image embedding samplers to produce embeddings that could integrate with text embeddings through cross-attention. This meant that existing LLMs and image models could be combined in a multimodal way, without modifying the existing trained weights whatsoever. 1 month later, 2 interesting studies in prompt design were released. LLMs are zero-shot reasoners, and chain of thought prompting elicits reasoning. The studies showed that when models were prompted in manners that incentivized the model to output incremental passages, logical performance improved greatly. These papers brought greater research focus into what was possible using intentional prompt design. 2 months later, Google published Minerva, which was Palm fine-tuned on 118 gigabytes of archived text, combined with inference techniques such as chain of thought prompting and majority voting. The model showed state-of-the-art performance on quantitative reasoning tasks. Later that summer, Bloom was released by Hugging Face and Big Science. The model is the largest publicly available LLM. However, its performance was somewhat lackluster, maybe due to undertraining. Fast forward to November, when ChatGPT was released and exploded in popularity, reaching 1 million users in just 5 days. While the technical details of the exact model supporting the chatbot weren't released, it's pretty certain the model was very similar to InstructGPT. ChatGPT has also been iteratively updated throughout its deployment. GPT-4 usage is available on ChatGPT through a paid subscription as of now. Also in November, DeepMind released Gato, which is a single generalist agent that operates in a multimodal domain on multiple tasks and even with multiple embodiments. From their blog post, the same network with the same weights can play Atari, caption images, chat, stack blocks with a real robot arm, and much more, deciding based on its context whether to output text, join torques, button presses, or other tokens. Gato's main technical contributions are in the realm of merging all the different modality data into a format the model can deal with. To summarize, they do this by modality-specific tokenization and embedding, then serializing all the results into a single sequence, which is provided to the model. Notably, Gato is well below state-of-the-art for all individual tasks. It is more of an exploration and generalization rather than a showcasing of performance. Further, being only just over 1 billion parameters, there's plenty of capacity to scale this approach. Early in 2023, with ChatGPT exploding in popularity, it was announced that Microsoft had invested another $10 billion in OpenAI. Also in January, Salesforce released a VLM titled Blip2. Blip2 improved performance over Flamingo despite having 54 times fewer parameters. Like Flamingo, Blip2 repurposed pre-training image models in LLMs. It did so using its querying transformer, which has a complex multi-objective two-stage training process that has some common components with Flamingo, but also some new ones. In February, Facebook released an open source Llama, which became very popular among the research community. Llama has GPT-like architecture with some tweaks inspired by Palm and GPT-Neo, and was the highest performing publicly available model. In the week prior to filming this video, Facebook has released Llama 2, which includes supervised and RLHF tuned models. In March, a lot of notable activity occurred. Firstly, GPT-4 was made publicly available through ChatGPT Plus. A technical report was also released, which lacked much technical detail, but did provide lots of insight to the state of the field. Secondly, Google opened access to Bard, which at the time was powered by Lambda, but later Palm, and currently Palm 2. Thirdly, Google announced Palm E, which is Palm but fine-tuned for generalist robotics tasks. To achieve this, sensor modalities are encoded into sequence vectors with the same dimension as the embedding space of the language tokens. Rather than explicitly training planning strategies, they allow the model to develop low-level policies by conditioning end-to-end. Fourthly, Google announced it would merge Google Brain and DeepMind, which it had acquired back in 2014. Lastly, in May, Google released a technical report for Palm 2, which, like GPT-4's technical report, didn't have as much technical details as a regular research paper. It did, however, claim very impressive performance, improving greatly over the first Palm. Okay, that's it for this series. I hope you found it useful. If you did, please leave me a like, and any other feedback is appreciated as well. Resources and citations are in the description, and once again, this video is available in article form. Link is also in the description.